Okay, so Michelle, I mean, we talked about FETs, but aren't there different kinds of FETs? I think there are different flavors.
Yeah, well, certainly there's one big difference. There's two types that are important. So the N-type MOSFET or an NFET is what we've just been discussing. Okay, so there what you have is you have IDS and VDS, and I'm going to reproduce this quickly, and you have curves where the numbers are all positive, right? This is sort of maybe not as clean as the plot on the last slide. 1 volt, 2 volts, and so on, right? As an example.
I see. So both VGS and VDS are positive.
This is positive.
And so is the current.
This is
IDS.
positive as in that model.
Okay, and then again, the schematic sort of looked like.
Well, so the symbol looked like this, right? And we had the gate here and the drain and the source, right?
Okay.
Okay. But there's another type.
Yeah, I've heard of them. They're called PFETs, right?
They're PFETs, or P MOSFETs. And there, what we have is it's like the dual. So here we're going to have VDS again, and here we're going to have IDS. But notice these are all going to be negative numbers. So here we have that, and so on. Okay? So VGS has to be a negative number. If it's 0, nothing happens. If you have a sufficiently large magnitude negative number, then you start running current. And so if VGS is then, 1 volt, minus 1 volt, VGS minus 2 volts, VGS minus 3 volts. So you see as the VGS gets negative, right, you have these values and everything is negative now.
Everything is negative. And so how do we, what's the symbol of these look like?
The most common thing to do is to put a circle, a little bubble in front of it like this. And if this is the gate, one thing you might notice is that particularly when PFETs are drawn near NFETs, sometimes the drain for that is down here and the source there. It really depends on the direction which current is running.
Okay, so we have here our duals, like the yin and the yang of transistors, P and N.
Yeah, and they're very useful. In fact, they're used in digital logic. Both types are used together to get very strong digital ones or digital zeros.
They complement each other.
They complement each other. In fact, that's the source of when you hear CMOS, complementary metal oxide semiconductor, comes from the fact that they're paired together in the manufacturing process.